Hey, math people. So you've done it a million times before. You're working through an inequality problem on a Saturday night for fun, and you run into a problem like this. So you get to the end of the problem. You've done all the correct algebraic steps, and you get a statement that just doesn't make any sense. In fact, the answer is so wrong, the answer that you got, that it's literally the solution set of everything that doesn't work. So what the heck did you do wrong? I know, you forgot to flip the sign. So you were probably taught this before. You were probably taught, in your algebra class that whenever you're solving an inequality and you divide or multiply by negative, you have to flip the sign. But have you ever wondered why? My suggestion in general, and what we're about to do right now, is just to break it into a simple case. Break it into the simplest version of what it can be, and then see from that what kind of came into play. So take the statement 1 is greater than 0. Is this true? Yes. Now we're going to try dividing both sides by -1 to see if the inequality still holds true. Take a look at what happens. I divided the left side by -1 and I got -1 naturally. When I divide that right side by -1, I still remain at that 0. Now I'm getting this bizarre statement that is -1 is greater than 0. So what the heck happened? I'm just going to replace 1 with a variable x to get a better view of this idea. When we consider x is greater than 0, 1 is greater than 0 like we just established, and 2 and 3 and 4 and 5 and so on. It's all those values to the right of 0. Now I'm going to very quickly divide both sides by that -1 again. If you remember in the last situation, all that happened was 1 turned to a -1. So all I'm going to do here is throw a negative in front of the x. Now I want you to consider that solution set again. When I plugged in a 1 here, -1 is certainly not greater than 0. When I plug in a 2 here, -2, again, certainly not greater than 0. 3, for some reason, works. 4, just kidding, nothing works. So what's going on here? What do I need to do to communicate that all these numbers actually now don't work? So coincidentally enough, remember all those numbers that just didn't work? -1 wasn't greater than 0. -2 wasn't greater than 0. How about we try plugging in those numbers just to see if they work? Well, if I take this -1 and I plug it in for x, I have a -1. That's just 1. And isn't 1 greater than 0? Same story for -2, -3, and so on. Actually, all of the opposite set of numbers, all those numbers that were negative, worked. So as far as our working solution set goes for this statement in particular, well, it flipped. But here's the thing, that solution set represented what it was to its core. It was who it was. And that's the thing about math. We're not trying to change who you are. We're trying to better represent who you are. So instead of flipping the solution set, I might need to do something else. I need to flip the sign. So when I do that process of flipping the sign, and I turn that, what was a greater than now into a less than, my solutions hold true. And that, ladies and gentlemen, is why you need to flip the inequality, that sign, when you are multiplying or dividing by a negative. And that's all I have. So I'm going to ask you to continue to math on, and I will do the same. I'll see you in the next video.